Okay, welcome back. This is Mark Stump. This video is not about photography. This video will be about the rule of 72, so math. Now, to review, let me start with this. This is how the rule of 72 would be used. If you think that you can grow your money at a rate of 8% per year, or you think you can grow your rabbit population by a rate of 2% per month, or you think that you can grow your bacteria colony at a rate of 5% per day, and you're wondering how long it would take to double your money, rabbits, bacteria, you can use the rule of 72. Now, I've already forgotten what I said, but this is what you would do. If you think you can double, if you think you're earning 8% on your money, you can calculate 72 divided by 8 is 9 and conclude that you will double your money in approximately 9 periods, in this case 9 years. If you think that your rabbits are growing at 3% a month, is that what I said before? It doesn't matter. If you think your rabbit population is growing at 3% per month, then you can ask yourself what 72 divided by 3 is. Seems like that's about 24. And then you would conclude that you'll double your rabbit population in 24 periods, which in this case is 24 months. If you think your bacteria colony is growing at a rate of 6% per day, then you would divide 72 by 6 and calculate that your bacteria colony will double in approximately 12 periods, which in this case is 12 days. So there it is. Now, someone whose identity I'm protecting was studying investing, and I mentioned the rule of 72 to her, and she looked it up online, and she came back and told me that 69 was actually a better number, and that we only use 72 because it's a nice round number. And I was somewhat horrified by this, and pretty sure that it was, at the very least, misleading, and as well as being wrong. Wrong because I didn't believe that there would be any one number, really, that would work. I believe that for different ranges, you might want to come up with different numbers. I was pretty sure that the rule of 72, that 72 itself was a good number if we're talking about something like 8% per period. If we're talking about other rates of growth, then I was pretty sure that other numbers would work better. I mean, if you're always going to be talking about 15 to 20%, then it would be better to use a number like 75. And if you're always going to be talking about something like 1%, it would be better to use a number like 69. But I would certainly not say that there's one number that makes more sense than the others. I think that's just wrong. So anyway, here's what I've done. And I think this will be very simple, very easy. Oh, I'm sorry, I have to tell you. If I had a larger chalkboard, I'd have written these things out, so I'll just tell you. I want R to be the rate. And more specifically, if we're talking about 8%, then I want R to be the number 8. I do not want R to be 1.08 or 0.08. I want R to be 8. If we're talking about 15%, I want R to be 15. And I want that because that's how it's used. That's how we want to use it in the rule of 72. You know, I want to divide 72 by 8 or 72 by 9. I would get into trouble if I tried, to divide 72 by 1.08 or by 0.08 and with the same interpretation. Okay, now I want n to be the number of periods, and I would like c to be that constant that we're seeking. So there it is. That's all That's all I'm going to need. Let me see if I can get this for you. I hope the glare won't keep you from seeing it. So, I have a small chalkboard. I might have to skip one or two small steps. It's my assertion that after n periods, this is what you have. That after the first period, you have 1.0, let's say r is 8. After one period, you would have turned 1 into 1.08. After two periods, you would have that 1.08 times 1.08. So you would be adding on 8% to the first period's 8%. And after three periods, you would have all that you had after two periods times 1.08. And so after n periods, that's what you would have. And as I said, the rule of 72 is about how long it takes to double your money. So in this case, I want to know when this will equal 2. Now, we also want to find some constant c, such that c divided by r equals n. That's really the whole point of this, is finding some c, I hope you can see that, such that c divided by r is the same as n. So somewhere up here, maybe I would have written, let c be such that c divided by r equals n. And then I make the substitution here. So I have 1 plus r over 100 raised to the power c over r equals 2. And now take the log of both sides. C over r times the log of this equals the log of 2. Now after I did this, I did look online, and I saw that some people get to here and there. It seems to me that a lot of folks online are doing the same thing, that someone did it this way and everybody else is copying that exact same what should I say, treatment or approach or method. But so they get here and they say, oh well, for small values of r, this is the log of this is approximately equal to r. I don't disagree, but at the same time I find zero need to make that approximation at this point. I have no desire to make that approximation. Let's see if we can just solve for c. C is what we want. Let's solve for c. So here it is. C equals r times the log of 2 divided by the log of 1 plus r over 100. Now, when I was in college, computers existed. Mostly supercomputers. But so, towards the end of college, I did have, well, every year, I had a Hewlett-Packard calculator every year. And I think in the last couple of years, I had the Hewlett-Packard 48GX. Or I started off with the 48SX and then the 48GX. And I loved that. I loved the 48. And I still have it. This calculator here is the HP 49G, and it's a piece of junk. I use it because I'm trying to wear it out. The 48 is just for special occasions. So I wrote a little program here. This is how we used to do things. I wrote a program here that allows me to input an R, and then it gives me the value of C. So if I input 1, for instance, as in 1%, and I push the button, it gives me 69.66. Now just for fun, let me input really small values, and then I'll come back to this. Let me input 1/100th of 1%. It gives me 69.31. If I input 1/100,000th, again 60. Well, I should have rounded a little bit before, but still now it really is 69.31. Before it was 69.318. If I put in 1 to the 1 times 10 to the negative 6th power I get 69.31, same answer I got before, out to the 10,000th place. Not that much different in the 100,000th place, one digit. So anyway, very small values, I keep getting 69. So far it would seem like maybe those people online have something on their side. For very small values of R, you get 69. Now, when I typed in 3, I wrote down some values. I typed in 3 and my program gave me 70.34. When I typed in 7, I got 71.71. I typed in 8, I got 72.05. When I typed in 12, as in 12% interest, I got 73.4. 15 gives me 74.4. And 20 gives me about 76, very close to 76. Just over. 76.04 if you must know. And of course that too is approximate. For some reason I just decided to stop at the 100th place. So here's one takeaway from that. If we're talking about very, very low interest rates, you might want to use 69. If we're talking about something like 8% per period, then you should certainly use the rule of 72. If we're talking about 15 to 20%, 75 would be a better number to use. You could use the rule of 75. And now clearly, what if you're making 100%, say, per year? If you're making 100% per year, how long does it take to double your money? Let me think. Now let me see, if I type in 100 in my calculator, what will it say? Sure enough, it says I should use the rule of 100. And therefore it'll take me 1 year. Well, obviously. Now, okay, so I have a few seconds left in this video, and I'm going to cover the case of a slightly different case. So far, what I've been talking about is this formula, and I claim this formula is completely right whenever you actually know the rate of growth in a specific period. It sometimes happens that you really don't know. It sometimes happens that what you know is a nominal rate. So, for instance, if your bank is paying you 2% interest in your checking account, and that's the nominal rate, but they calculate and compound interest daily, for instance. Okay, well then, actually, then you would be able to use this formula. You would know the. It wouldn't be too tough to calculate what 1/365th part of two is. And you could use this, but my point is going to be that those are all very small values of R. And we've already seen that for very small values of R, you should use 69. In the limiting case, the answer is 69. In the limiting case, you basically got the natural logarithm of 2. Where is that button on this junky calculator? So yeah, 69.31. And yeah, in other words, exactly what I got, 69.3147. The same answer that I got when I put in an R of 1/1,000,000th. Out to several places. So if you have a nominal rate, then use the rule of 69. If you have very small values, 1%, 2%, sure, go with 69. Around 7 or 8%, stick with the rule of 72. And if you want to talk 15 or 20, rule of 75. And of course, if you're growing your money at 100% a year, then you don't need any fancy rule. It's obvious that you double your money every year. I'll just mention that one for fun. So there it is. Thank you for watching.